complex analysis module 4, Taylor and Maclaurin series problem solving session. So the contents are, we will discuss what is Taylor series and Maclaurin series. This is very important section, and we will discuss some few problems. Okay. So what is Taylor series? The Taylor series of a function f of z, that means if f of z is analytic, that is one more condition, then Taylor series of a function f of z, which is an analog of Taylor series in real. That means we already studied Taylor series in calculus. So similar. So f of z is n equal to 0 to infinity a n z minus z naught all power n, where a n is f nth derivative of z naught divided by n factorial. Okay, so this is of the form f of z equal to, if you expand this, that means sigma n equal to 0 to infinity f nth derivative at z naught. So we are finding Taylor series at a point z naught divided by n factorial z minus z naught all power n. So if you expand this, we will get f of z naught plus f dash of z naught by 1 factorial z minus z naught plus f double dash of z naught divided by 2 factorial z minus z naught whole square plus etc. Okay, so this is called Taylor series of a function f of z at a point z naught. That means the condition is f of z must be analytic. Now we will discuss what is Maclaurin series. So this is a special case of Taylor series when z naught is equal to 0. So here if z naught equal to 0, then we will find the Maclaurin series. So f of z is equal to, this can be written as Maclaurin n equal to 0 to infinity, n equal to 0 to infinity, f nth derivative at, instead of z naught we have 0 by n factorial z minus 0 whole power n, that is z power n. So this is f of 0 plus f dash of 0 by 1 factorial z plus f double dash of 0 by 2 factorial z square plus etc. So this series is called the Maclaurin series. So Taylor series is this expansion and Maclaurin series is this expansion. So there is one more important property is Taylor series is unique at a point in some neighborhood. Okay, so Taylor series is unique. So what we will do is we will find Maclaurin series of functions, basic functions, and we will use that to find the Taylor series and other Maclaurin series, because if you find a series expansion of a function at a point, then that must be Taylor series because of the uniqueness of Taylor series. So first we will find the Maclaurin series of sine z. So here I will write here solution. So here given f of z is equal to sine z. Okay. So Maclaurin series is, what is the formula? F of z is equal to sigma n equal to 0 to infinity Maclaurin series of f n the derivative at 0 by n factorial into z power. So this is equal to f of 0 plus f dash of 0 by 1 factorial z plus f double dash of 0 by 2 factorial z square plus etc. Okay, So now if we find f of 0, f dash of 0, f double dash of 0, f triple dash of 0, etc. And if we substitute, നമ്മൾ ഇതിൽ substitute ചെയ്ത് കഴിഞ്ഞാൽ Maclaurin series of sin z കിട്ടും. Okay, so first we will find what we have f of z equal to sin z. Then what is f of 0? Sin z, instead of z it is 0, sin 0 is 0. Now what is f dash of, so we got f of 0. Now what is f dash of z? Derivative of sin z is cos z. Okay, so what is f dash of 0? Cos 0, that is equal to 1. Now I find f double dash of z is equal to cos z derivative minus sin z. So f double dash of 0 is 0. So similarly we will find f triple dash of z. Derivative of minus sin z is minus cos z. So f triple dash of 0 is minus cos 0 is minus 1. Now f fourth derivative of z is minus cos z derivative sin z. So f fourth derivative of 0 is sin 0, 0. So we will find a few terms. Okay, so this is f fifth derivative of z is equal to sin z derivative cos z. So this is equal to f fifth derivative at 0 is cos 0, 1, and so on. Okay, now how to find out? So now we will write. Okay, we will write. So we find this. Now we will write Taylor's Maclaurin series of sin z. This is equal to, we know that sigma n equal to 0 to infinity f nth derivative at 0 by n factorial z power n, where f of z is sin z. So this is equal to f of 0 plus f dash of 0 by 1 factorial z plus f double dash of 0 by 2 factorial z square, etc. So which implies sin z is equal to f of 0 is 0 plus f dash of 0 is 1 divided by 1 factorial z plus f double dash of 0 is 0 by 2 factorial z square. Next we have f triple dash of 0 by 3 factorial. Okay, 3 factorial z cube plus etc. So this is minus 1 by 3 factorial z cube plus etc. So you can write sin z is equal to, we will get a pattern z minus z cube by 3 factorial, next here 5 plus 1 plus z raised to 5 by 5 factorial minus etc. So this we can written as sigma n equal to 0 to infinity. So in general what will be the nth term? Minus n 1 power n z raised to 2n plus 1 divided by 2n plus 1 factorial plus etc. So this can be written as minus 1 power n z raised to 2n plus 1 by 2n plus 1 factorial. Okay, so n equal to 0, then z by 1 factorial. So that is z. N equal to 1, then minus z cube by 3 factorial and so on. So we can find the Taylor series or Maclaurin series expansion of sin z. So similarly, so the second problem is I will. So we want to find out second problem is cos z. So I will give a. minute, minute. I will delete this. So I will erase this all file. Okay. So okay. So next is cos z. So similarly we can write a cos z. Cos z is uh, f of z. You can take cos z, and I will give you only the. You can practice this. So cos z answer will be like you will get 1 minus z square by 2 factorial plus z raised to 4 by 4 factorial, etc. etc. You will get minus 1 power n z power 2n divided by 2n factorial plus etc. So this is a cos set Maclaurin series. So you do same by same procedure you can do cos set. Now I will do the third problem, sin hz. So if f of z is equal to sin hz, then we know that by Maclaurin series expansion, we know that f of z can be written as f of 0 plus f dash of 0 by 1 factorial z plus f double dash of 0 by 2 factorial z square plus etc. So now similarly what we will find, f of 0, f dash of 0, etc. So I will find here f of z is equal to sin hz. Okay, so what is sin hz? Sin hz is e raised to z minus e raised to minus z divided by 2. This is hyperbolic sin. Then what is f of 0? This is e raised to 0 minus e raised to 0 divided by 0. Then f dash of z is sin hz derivative is cos hz. Then f dash of 0 is cos hz. So we have cos hz is equal to e raised to z plus e raised to minus z divided by 2. So which implies cos h0 is e raised to 0 plus e raised to minus 0 divided by 2. 2 by 2 which is equal to 1. So this is 1. Now f double dash of z is again sin hz. Cos hz z derivative is sin hz. F double dash of 0 is again 0. F triple dash of z is again, if you find derivative of sin hz, this is cos hz. Then f triple dash of 0 is 1. Now similarly fourth derivative of f is derivative of cos hz. This is sin hz. Then fourth derivative of 0 is this is again 0. So we got a pattern, right? So what we can write? So sin hz, we know that Maclaurin series of sin hz is sigma n equal to 0 to infinity, 0 to infinity. We know that f nth derivative at 0 by n factorial z power n, which is f of 0 plus f dash of 0 by 1 factorial z plus f double dash of 0 by 2 factorial z square plus etc. Okay, so this is equal to f of 0 0 plus f dash of 0 1 by 1 factorial z plus f double dash of 0 0 by 2 factorial z square plus f triple dash of 0 1 by 3 factorial z cube plus etc. So you already get a pattern. So what will be the answer? So 0 z plus z cube by 3 factorial plus z raised to 5. If you continue like this, 5 factorial plus etc. So this, so if you continue like this, you will get z power 2n plus 1 divided by 2n plus 1 factorial plus etc. So this is equal to sigma n equal to 0 to infinity. This you can written as in Taylor series form. This is z 2 raised to n divided by 2n factorial. So this is called Maclaurin series of sin hz. Okay. So similarly, you can do log 1 plus z and also 1 by 1 minus z. So I will do 1 by 1 minus z. Okay, so I will do. Okay, so find Maclaurin series of Maclaurin series of 1 by 1 minus z. So solution, if f of z is given as 1 by 1 minus z. Now we know that Maclaurin series expansion is of z is f of 0 plus f dash of 0 by 1 factorial z plus f double dash of 0 by 2 factorial z square plus etc. So now we will find so we already know f of z is equal to 1 by 1 minus z. Then what is f of 0? So just what we have to do is find f of z, then you find out f of z, f of 0, f dash of 0, etc. Okay. So this is 1. F dash of z is 1 minus 1 by 1 minus z all square into derivative of minus z is minus 1. So 1 by 1 minus z all square. So f dash of 0 is 1. Now similarly, f double dash of z is, can find the derivative, minus 2 into, okay, 1 minus all cube into derivative of minus z. So 2 factorial divided by 1 minus z all cube. So 1 into 2 is 2 factorial. So f double dash of 0 is 2 factorial. Similarly, f triple dash of z, if you find again derivative of this, so 2 factorial you can take outside into derivative of 1 by z, 1 minus z cube is minus 3 divided by 1 minus z raised to 4 into minus 1. So 2 factorial into 3, minus and minus get cancelled. 2 factorial into 3 is 3 factorial all raised to 4. So f triple dash of 0 is 3 factorial. And so on. So on, we will get f fourth derivative of 0, you will get 4 factorial and so on. So now we will find Maclaurin series 1 minus 1 by z is equal to, so what is f of 0 here? of 0 is 1 plus f dash of 0 1 by 1 factorial z plus f double dash of 0 2 factorial divided by 2 factorial z square. Similarly, f triple dash of 0 is again 3 factorial divided by z cube plus etc. So you will get 1 plus 1 factorial is 1. 1 plus z square plus z cube plus etc. So 1 by 1 minus z is sigma n equal to 0 to infinity z power n. Okay. So if you want to find out the radius of convergence or where this is valid, if you take okay, this is valid when mod z less than 1. Okay. So in other, when mod z greater than 1, you cannot write this as in this power series. You already know this is called geometric series. Okay. Now we will use this and find Maclaurin. Okay, so Maclaurin series. Next question is find Maclaurin series of f of z is equal to 1 by 1 plus z square. So now what we will do is we know the basic series representation and we will use that series to find the existing this type of series. So we know Maclaurin series expansion of 1 by 1 minus z is equal to 1 plus z square plus z cube plus etc. Now, which implies what is 1 by 1 plus z? So this is something like 1 minus of minus z. So now what we will do is we will replace z by minus z here. So what will be the expansion? 1. We replace z by minus z plus minus z all square plus minus z all cube plus etc. So what will be the expansion of 1 by 1 plus z? By the uniqueness of Taylor and Maclaurin series, you can easily write this is 1 minus z plus z square minus z cube plus z raised to 4 minus z raised to 5 plus etc. So this is equal to sigma n equal to 0 to infinity minus 1 power n z power n. Now in this case what we have to do, we have to find out Maclaurin series of 1 by 1 plus z square. So 1 by 1 plus z square uh, is equal to. So we want to find Maclaurin series of 1 by 1 plus z square. So we already know the Maclaurin series of 1 by 1 plus z. Now we will use this series representation to find this. Okay. So so, so we have 1 by Maclaurin, we have Maclaurin series of 1 by 1 plus z is equal to 1 minus z plus z square minus z cube plus z raised to 4 etc. Therefore, replace to find Maclaurin series of series of 1 by 1 plus z square. What we have to do is we just replace z by z square. So here, so this is 1 minus z square plus z square all square minus z square all cube plus z square all raised to 4 minus etc. So this is equal to 1 minus z square plus z raised to 4 minus z raised to 6 plus etc. So this is the Maclaurin series expansion of 1 plus 1 by 1 by 1 plus z square.